Hello again, IGs. We're going to do exercise 14.3 now of the linear programming, which is chapter 14. So I'm going to teach a little bit and show you what we're going to do here, but there's really no new work, just some more application of some old ideas. So in exercise 14.3, they give you question 1 there, and they ask you to draw on the graph 3 of these inequalities. Now the first one they want is the y is less than or equal to x. Well, let's write that here quickly. Y is less than or equal to x. Okay, and well, if we made y equals to x, what kind of line is that? Well, if you're familiar, remember it's a gradient of 1 with the x. There is a 0 for the c value. So this would be a line that goes through 0 and has a gradient of 1. It's a straight line that does the following. Okay, I'm just going to draw the equals to ones now. We're going to come back to the less than in a moment. The second one they want is y is greater than 1. So firstly, question is, where is y equal to 1? Well, let's make it over here, and we'll make it 0 degrees. There we go. Y is equal to 1 is a straight line that is parallel to the x-axis over there and runs through the value of y equals 1. I'm just going to put the 1 in for you over there. Okay, that's the 1. And the third one they want is x is less than 5, so we're going to need to know where x is firstly equal to 5. That's probably somewhere around about here. And again, we'll draw a straight line. There we go. Right, so this is x is equal to 5. Okay, and remember, sorry, let me just undo that 5 there on the x-axis. Oh dear. X is equal to 5. Remember, there's 1, 2, 3, 4, and 5. Okay, happy with that? Okay, so there we go. We've got all 3 lines drawn. Okay, now the thing is, let's see what they said with in terms of the inequality. For the first one, they said y must be less than or equal to, so that must be everywhere underneath. So I'm going to shade for this line everything underneath, and we leave the line solid because it is including the equal to. So everything shaded beneath. I'm actually going to go all the way here. So we just shade, lots of shading. Okay, that's everything underneath that line. For the second one, they wanted y is greater than 1. So that was, and I'm going to use a different color, everything above this line. Yes. There we go. Everything above that line. Now, being strictly greater than, it means that also this line should be a dotted line. Okay. So we just want a nice dotted line there, not a solid line. And for the third one, they wanted everything where x is less than or equal to 5. So that's everything to the left-hand side. And again, I'm going to use different colors, so we'll go with the green. Everything to the left, and because it's equal to on this one, we'll keep the line solid for x is equal to 5. That's the vertical line going up through the value x equals 5. Now, if you see what we've got here, there's only one place on the graph where there is red, blue, and green shading. Okay, red, blue, and green shading. And that is, and I'm going to use a highlighter to mark it, that is this triangle over here. Yes? Okay, so that triangle has red, blue, and green shade. Everything else has either got blue and green, or just blue, or just green, or red and blue, or red and green, but no blue, green, and red. So in other words, once we've shaded everything, okay, we actually are only interested in the section that is included with all of the shading. Okay, so it says on the same, this is what the question said originally. It says, leave unshaded the region which satisfies all of them simultaneously. So strictly speaking, to answer their question, we should have left this section with no shading whatsoever. Okay, so that area is unshaded. So this is why you probably want to do your shading in pencil, but there we go, we've got an unshaded region. Now that's really all this is about. It's just putting a few inequalities together and getting an unshaded region. This stuff has incredible value in analyzing business principles. So you can use linear program to analyze all kinds of different situations where you want to work out which is the best region to choose solutions from. And certainly any point within that unshaded region in this case would be a solution that you could use. Now, I would like you to do number 2, 3, and 4 of exercise 14.3 just to get some practice. And then we're going to look at exercise 14.4 from there. In fact, I'm going to give you some homework. So exercise 14.3 is number 2, 3, and 4. Exercise 14.4, you can do number 1 and number 3 and number 4. And then you can try the student assessment number 2. Okay, that should keep you busy. I will do some work through of those as well so that you can see what they should look like, but I'll only post those a little bit later so as to give you some time to try these before you see the answers. Alright, enjoy the rest of your day, and that's chapter 14 actually done now, so we'll move on to 15 very soon.